Nice. Say door. The final ready to close the forward door at this time.
Right? Alright, good. It's right. Right.
We're happy to have you with us today on Alaska Airlines Flight 237 with service to Los Angeles. Your crew today is Captain Dennis Buck. First officer, Tom Perkins, and I'm here with Music Kevin Harlow, Erica, and Dorothy. Safety is our first priority. We'd appreciate your attention while we share some important safety information. Please review the safety information card in front of you, which illustrates what to do in the unlikely event of an emergency.
Hello, hello, hello. Welcome, everyone. Actually, we can keep going. Welcome, week 2, lecture 2. We're here already. Goes so quick. Let me get rid of this. How are we all going? Good? Volume okay? Everyone can hear me okay? We're all feeling good? Keeping out of the rain? Hello, Felix. It's a bit quiet. It's always my problem. I gotta figure out if I can boost this somehow. Oh, I see what it is. This is way too low. Okay, how's that? Is that good? This should be good. Give it a second to catch up. Awesome. All right. Very nice. Good, good, good. Too loud. Yeah. I'm a pretty loud person, so hopefully if it's too loud now, you got to let me know. I can see it might be clipping a little bit, so I can adjust. I'm always trying to improve, you know. There's a lot of things that go into streaming on top of delivering the actual content in a course, but we are trying our best. Awesome. All right. Well, it's 5 past, so we've got a lot to get through in this lecture today. So this one's a little different. If we have a look at Web CMS, you can see here that we have 3 lecture topics today. Actually, 4. Yeah, 4 lecture topics. So what you can sort of think of these as 4 smaller 30-minute chunks of content that'll obviously be delivered all in this lecture. But what I'm going to try and do is actually restart the stream in between each section so that it generates a separate video for each section. So for those of you who are watching it after the fact, or for those of you who are watching it now, want to rewatch the videos later, you can pick and choose a bit better between which video you want to watch, if that makes sense. So I might give it a go. I hope it doesn't break everything, but after the importing in paths lecture content, I'm going to restart the stream. And you should all, it's the same link, so you should all just stay in the chat and stuff once it restarts, but you'll be able to jump into all 4. Okay. Me wondering when the lecture will start. I don't understand. Ah, okay. Your headphones were unplugged. Okay, so, oh, I gotta refresh this page actually. Thank you to a student, Ben, who went ahead and generated the PDF documents for these lectures. So you can click importing in paths, view the PDF, and we have the exact lecture content on the slides that I'll be presenting today in a PDF document. And we're even looking at improving it a bit better for the code highlighting. So you can run through this document yourself and sort that out. And yeah, for those of you who want to volunteer your time to create the checkpoints on the YouTube video, I would love that. That would be awesome. Okay, so let's get right into it. In the first lecture on importing and paths, a really important topic. Okay, all looks okay on the stream. Yep. Importing and paths. So importing shouldn't be really anything new to you guys conceptually. So in C, you imported libraries, right? You might import local libraries that you wrote yourself or that your team members wrote or that we wrote at CSE, or you could download a library and import the library that way, or you could be importing a standard library, which means a library that gets bundled typically with the language itself. So in this lecture, we're going to talk about how library importing or file importing works in Python, how we can do it, the different ways that it works, and some of the differences that you might not be familiar with in terms of how C does importing and Python does importing. So you can see this is an example of some C style importing. So we use the hash include statement, and then we proceed with the name of the library file that we're trying to include. And if you remember in C, there were 2 types of syntax to denote if it was a standard library that we were importing, or if it was one of a non-standard library import. So maybe our own file or someone in our team that we've created ourselves. So this shouldn't look too foreign to you. Now Python's very similar. Let's get some Python code up here. Here we have a really simple Python file called import2. Hopefully you can all read this okay and then zoomed in okay. Oops. Okay, import to. And we can see at the top of the file here, we have two imports. One called import system and one called import CalMath. And now this leads to one of the major differences between C and Python is that in Python, we have no way to denote whether we're importing a local library or if we're importing a system library. So you sort of just have to know based on what the name of the library is. Now, where do we know, how do we get all these system libraries? How do we know what's available to us in Python? Well, we can go off to the Python standard library website. We can select the version of Python that we're running. So in our case, we're running 3.7. And you can see here all the different libraries that come available to us in Python that we need to import. So by default, these aren't just available in language, we need to import them. And there's some really common ones. So one of the really common ones that we'll talk about for a second is called SYS or sys for system. Here it is here. System specific parameters and functions. So what's all this about? Well, you can see here that if you import system SYS, you get access to all of these things, and the documentation describes what those things are. So in our little Python program here, you can see we import system, and then we get access to, for example, system.argv. So for those of you who are paying attention and you remember from C, argv, or the argument vector, is the arguments passed into the execution of a program. So you call a program, you pass in some arguments, and those get sent in through sys.argv, just like C. Now, another thing we have here is this CalMath file. I might zoom out just a bit. Now, CalMath is really simply just a Python file that we wrote ourselves, so it's not part of the standard library. And it defines a function called days into years that accepts two parameters, does some logic, we don't really need to worry about it. It's got this other quick run method, we don't really know what that's doing yet, and some other stuff going on here. But basically what we really care about is we've got this file called calendarmath or calmath that has this function called days into years, okay? And you can see in import to, okay, and these files are just sitting next to each other on the disk. In import to, we can just import that local file, and it will look first in the local directories for anything called calmath, and it will then try and import it. Now, if we have a look at what we actually do in this file, we can see here that here we're calling sys.argv, right? So this is a method that we've. So I'm just going to turn off something. I have an extension that shows git history, disable, reload, and it's just annoying me a bit. Okay. Useful in industry, not useful when you're giving a lecture. That's better. So you can see here that now I can call this argv, which is a variable, on this system module that I imported. And I'll demonstrate how that works in a second, but what we're really caring about at the moment is the importing of the modules themselves. But you can also see down here that we have this, we are calling that days into year method on the calmath module. And that's just this method here. Okay, so let's have a look at the slides for a second again. Yeah, just time for a demo. So let's sort of run this in a couple different ways and see what's happening here. So the first thing I want to do actually is just run this days into year method directly from the calmath file itself. Okay, now I'm just going to get rid of this for a second, and I'm just going to run Python 3 or whatever your Python interpreter is labeled as calmath. Now, what's going to actually execute when I run this? Well, I'm calling the calmath file, so this file is going to run. So the interpreter is going to scan through this file line by line. This is a function definition, not a call, so it's not going to do anything. This is a function definition, not a call, it's not going to do anything. And then we get down to here. If name is equal to main, call quick run, and then just call quick run again. So we probably don't need that for now. So this is something that we're also going to talk about today, and something that I think causes a lot of confusion to some Python programmers and probably to a lot of students. So who's seen this line before? You'll see it in a lot of Python files. And seemingly it's like, what does it actually do? Some people say like, oh, this is the main function, like in C, but it's not really the main function. It's not a function, is it? Is it a function? Yeah, it's not a function. So I've heard this called the main guard before, and it acts sort of like the main function in C. But what it's really doing is saying if the name of the module that's being called is main, then we do the things that we want to do if this program was called directly as this file. And I'll explain a little bit more about what's happening here. But let's just run this. And we're going to assume right now that this will run because this is main and we're calling this program, right? And you can see, okay, something happened. So we called this quick run method. This quick run method prints 2 lines. And in the 2 lines, it's just got some string formatting. And it calls this days into year function with some parameters. And basically, it's just counting how many days a particular month and day is into the calendar year. So we don't really care about what it's doing. In fact, we can even sort of minimize that to simplify our codes. We've got some function that does something and I'm calling it in my method. Now, why is this sort of running? Well, that must mean that name is main because this is an equivalent operator and it's saying is name main. So we can actually print that out here and run this again. And you can see that, yeah, the name, this magical variable called __name __, some weird variable that we've just gets defined for us in Python, has been automatically assigned the value main. Why is this? It's because Python's trying to give us some information about how this file or how this block of code was called. Now, it's just been called directly by the Python interpreter. Well, what does that mean? It means the Python interpreter assigns name main. Okay? That's all it's doing. It's going, oh, well, yep, the user or the operating system just called calmath directly, so it's just named main. I'm going to name it main. It's the main file. Now, whenever you see this ___ wrapping a variable, that usually means it's an inbuilt variable to Python that just is defined by the Python interpreter in the Python runtime for us. So we did not define this value. The Python interpreter, before it even ran any of our code, assigned name __, the value main. So I know that's a bit tricky to understand, and this is where again, the philosophical difference between C and Python starts to show its head. In C, nothing really happens for us. We have to do it ourselves. In Python, it's trying to do some stuff for us to help us be more productive programmers. But otherwise, nothing crazy is happening here. We're calling a method. It's calling quick run. It's calling this function twice, printing out the results, and we should be pretty happy with what's going on here. Now, some questions in the chat, some really good questions. Let's see here. Does it always return main? No, and we're going to see that in a moment. Otherwise, there would sort of be no point to it. Why do we use it? It's called the main guard, and what it lets us do is say, is this code being run from an import to another program or another Python file, or is this file being called directly? If the file is being invoked directly, then this will evaluate to true, and we can do something or not do something depending on that logic. Okay? Let's have a look at now where we're calling in this other file import to. Okay? In import to, we are importing calmath. All right? Then we're going to call calmath depending on if there's enough arguments passed. So what this import to is actually saying is that, hey, get the arguments passed to the program and make sure it's exactly equal to 3. So let's break this down a little bit line by line first. Okay, so let's just print sys.argv. Let's see what this does. Now, I'm not going to call CalMath, I want to call import2. And we can see that, well, let's actually get rid of that even for a second, reset this. We can see that we get this list being printed out with just import2. Well, what is this? Well, I printed out all the arguments to the invocation of this program. What are those arguments? Well, there's just one, and it's called import2. So now I can say, well, so the first is the number of the number of the month. So let's do today's date actually. So it's the 23rd of February. So that's just a 2. And then it's the day of the month, and we'll put 23. If I run that, you can see those arguments are being piped through to this argv variable. Okay, this works really similarly to how it works in C, except in C you also get argc because you don't know the length of it, right? Because here we can do length because it's a list, and we spoke about lists yesterday, and here we'll get 3 back. So we don't need an argc in Python. I bet you to your question there, Austin. The argc is already built in because this is a Python list. So that's what argv is, nothing new here. Okay, then we can also import CalMath, and then we just have some logic here to say, so make sure we have exactly 3 parameters because we're going to need them in a moment. And then argv is just a list. So I can use 1 and 2 to get that 2 and 23 out from the argv and pass them into the CalMath days into year. Before we even run any of this, let's look at something interesting. When I run this, something's getting printed here, but I'm not printing anything in this import2 file, right? So what is this? Where's it coming from? What the hell is going on? Well, Python is still importing CalMath. It's not using it after it's imported, but it's still importing CalMath. So Python comes along, jumps to CalMath, and runs through the import, okay? And you can see in the import, I'm printing the name, that magical name variable inside of CalMath. And it's not main, is it? It's called CalMath. It's the name of the module now. And that means that this won't evaluate to true, so this won't run. So why did we want this functionality? Well, if we didn't have this check, quick run would just be called. And we would start running this like default behavior in CalMath, even though I called nothing in import2. I didn't want to do anything with CalMath yet. So how do we avoid that? That's why we have the main guard. Now, with the main guard, this name is not being evaluated to main, so this quick run does not run, and I have more control over how and when I want to use this CalMath library. Does that make sense to everyone? You might need to let that sit in a little bit, but basically it's letting us control whether we should have some default functionality that should run as like a main function when we just call a file, or if we actually want to just use the file as a library and call things sort of ad hoc when we want to. Now, we should actually get this running generally. So we make sure we have 3 arguments. We sure do. Then we can call this out and we print it out. So if we clear the terminal and we run this, you can see that today is the 82nd day of the year, which is pretty crazy. Cool. How was that? It's not? Okay, well maybe that function's not right. We don't really care about the function itself. Month and then day. Yeah, it's only like 40 something, isn't it? Anyway. Oh, it starts at 0. Yeah, you guys are right. You guys are right. That's what it is. Yeah, something like that. 0 would be January. 1 would be Feb. Yep, cool, thanks, good catch. Always an off by one error, huh? So we always make it. So maybe this function could be improved by accepting that as a string called Feb or something. We're not worried about the actual functionality in terms of leap years and stuff like that. What I want you to think about is why this main guard functionality is useful, okay? So any questions on that? Let's go for it. Okay, so I've spoken about what this name variable is used for and how it changes its value depending on how the file was invoked. So here's a few ways that we can import files or modules or libraries into Python. It's not like C, where you just have to have the file in the directory or at some path that's on the path variable, and then you do your import. There's a few different ways we can do it in Python. So method 1 is called the wildcard method, and it's basically saying import everything, import star, from some library. And that just brings in all of the different components of that module, like days into year, like quick run, and just pollutes the namespace of import2, let's say, with those methods. So you wouldn't use, so let's actually sort of demonstrate that. So we can go import everything from CalMath. It doesn't like that, maybe because it's not a actual module. Not, oh, unless that's just sort of not working. No, it doesn't like it. Maybe this is an old Python syntax, or maybe the module needs to actually be installed. But basically what it does, or I've got some settings that aren't letting me do it, but basically what it does is it comes along and it goes, okay, there's this days into year method inside of CalMath. I'm going to make it available just as days into year, and you just call it like this. Now, the reason why we don't advise doing this method is that it pollutes the namespace. So namespaces, if you're not familiar with the term, something that's commonly dealt with in languages like C# and Java, for example. But the main idea of it is just that, imagine that you're importing from two libraries, and they both happen to have a method called days into year. Well, now you've got like a clash, right? Which days into year should I be calling? It's not clear because I've just took everything from some library and put it into my module. So to avoid that, we can specifically import, so to avoid the pollution, we can specifically import specific modules that we know we want to use from a particular library, and only those will be brought in and polluted in the namespace. But they are still, you wouldn't call lib.1 in this case. It's just you have access to this one thing, whatever it is, right? And then finally, we have what's generally another method here where we just import everything. Basically, we import the lib module. But, and our documentation here makes a lot of sense. It's useful if that item needs its context. So this is what we were doing in import2. We imported sys, for example, but I still had to do sys.argv. So I have access to everything on sys, right? All of these things, but I call sys.getProfile, for example. So there was a question is, what's the difference between methods 1 and 3? Well, with method 1, right, I could just say use argv directly without this sys import or context. Whereas with method 2, I'm only importing the thing called sys, the module called sys, and then I can use everything that's on it, but with the context, so sys.argv. So generally, I prefer the third method because it's the most precise, but you do get everything in. That's the thing. So generally, you want to use either 2 or 3. So the benefit of method 2 is that you only bring in 3 things that you know you need and nothing else. With method 3, you get everything. So generally how it works is that you might have some library, okay, called lib, and you know that, hey, we're going to use basically everything in this library. We're really utilizing this library. It's got a lot of core functionality for our system. So you would use method 3. You might have another library that you really only need 1 or 2 functions, just some helper functions, so you could import them more explicitly, but more limited, so there's less stuff in your program. And here's some information that pertains to the strategy that the Python interpreter takes to find and import. Now, our imports are sort of vague, right? Import SYS, or where is that coming from? Is it local? Is it a module? Is it a library? Standard library function? What's going on? So here's the order that Python sort of goes about trying to find where this module is stored. So at first, it's looking at one of the pre-built binaries. What does that mean? That's the standard library. So that's all of these ones. These are the pre-built binaries that get shipped with Python. Second, it will look in the directory that your Python process was invoked in. So it will look for CalMath because CalMath is in the directory next to import to. So basically, at first, it couldn't find a system library called CalMath, and then it looked for it locally, and then it found it. And then finally, it will look at anything on sys.path. So what is sys.path? We can print that out. But basically, it's the path variable that contains a bunch of directories that we've told Python there might be modules, libraries or modules here. And so we'll run through that path variable in order, trying to find anything named what we've imported. And that's basically it in terms of the strategies for importing and the different ways we can import and the different things we need to consider when we're importing. So let me have a look at some of the chat. So does import CalMath just pull all the code from CalMath at the top of the file and then run the file from the top to the bottom? Absolutely. So it imports it interprets the CalMath file line by line, and it needs to execute it to know, sort of what to do and to load the definitions of the functions, and then it makes those function definitions or variable definitions available in the CalMath object in this file. So it basically goes off, computes everything it needs to compute, and stores them in CalMath dot, for example. Stores them here. And you can see here's all some built-in stuff that is just on every module, and then here are the 2 things that it actually had to go off and compute. So to recap, method 2 imports certain things from a library. Oops, yep. Method 3 imports a whole library. Absolutely. Method 1 also imports the whole thing from the library, but not in the context of lib. So method 1 goes off and just gets this thing called days into year and makes it available here. But method 3 is like making it available, but in calmath.days into year, if I can spell it right. And the reason why this is preferable is because if I've got this other, if I've got this other CalMath file, which also has this days into year method, and I'm doing the star approach, then which days into year, if I'm importing both, right? Which days into year am I actually referring to? I don't know. So by using it with the named approach, I'm being very explicit in terms of which one am I calling. It's the one in CalMath. Scooby, is sys a default Python? No, so system is a default Python here, I brought it up earlier, SYS. It's a really important one that contains all the different system invocation specific parameters and functions, like the arguments to the program. It's a bunch of different stuff. You can go off and read the documentation if you're curious. So, I think that's a good nugget of a lecture. Now here, I'm going to try the stream reset thing. Well, what do you guys reckon? Should I do the stream reset, or should we just get someone to do chapters after the fact? What do you reckon's better? Yeah, Scooby, it's like SCD.io, but SCD.io is standard input-output specifically. System is higher level. But yes, it's like that. It's a built-in library. Yeah. We got two answers and two completely different answers. Or maybe one of you guys could do the timestamps. Do we want to try that? So I'll just keep going then. I'll try keep going, and we'll see how it goes. And if not, next week we can try something different. Huh? We'll try chapters this time. Okay. Have some water. Quick reset. Let me get this closed. Let me get 2.4 open, and let me get it sized upright. Oops. And let's switch over to our slides here. Okay. Lecture 2.4, packages. So we spoke about importing modules, but the modules that we imported were either standard library modules or modules that we wrote ourselves, right? What Python has sort of part of the ecosystem is a way that we can install these modules in a specific project and lock the module versions for the project that we're using. So Python has some inbuilt ecosystem that C does not have anything sort of really like this. That we can install modules that were written by other programmers or other teams and use them on our system, and how to manage the installation of these modules, basically. And there's a few different ways to do it, and it's not clear what the best way to do it is. It depends on the project. So we're going to show you two common ways to do these, and these are two common approaches that I've used personally in industry and in my own projects. So, Python comes with a number of standard libraries, like we saw with the system module or the math module. Basically, any library here comes with the Python language. But just like in C, this doesn't contain everything that you might want to do or might want to have a library for in Python, right? This is just the really common stuff that you pretty much always will need. So what Python did was that they said, well, rather than have everyone have to go to repositories or links and then download C and header files or download Python files and compile those Python files, and they might compile differently, blah, 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 blah. Part of the Python ecosystem is something called pip. And pip is the package manager for Python. And what it does is it comes along with our Python interpreter and lets us install a specific version of a published Python module in our Python environment. So I know I said a lot of words there, but it should make a lot of sense. And so just like Python, there's a few, it matches the Python version system exactly. So there's pip3, that's the Python 3, there's pip, that's the Python 2, etc. So when you install Python 3.7, you automatically get the associated pip to 3.7 sort of version. So let's have a look at one of the most prolific Python modules ever. It's a module or a library called NumPy, Numbers and Python. It's a data science number manipulation library used heavily in data science. Just to show you how prolific NumPy is, let's look at how many stars it has on GitHub. 19.7 thousand stars. I mean, if you're familiar with this, you can get an understanding of the scope and the size of this project. It's a huge project that underpins so much of what happens in data science and Python. And it's a really, really cool module. It does so many amazing things. And you have zero hope of building something, to the scope of NumPy yourself if you need to do these things. So we don't want to build everything ourselves. We want to bring that functionality in, and that's what pip helps us to do. And yeah, it's a package manager, just like APT is a package manager for Linux programs. It's a package manager for Python. So here I have this import NumPy, and I've actually got a named import here where I'm renaming what I'm calling that NumPy module. Now, NumPy is not a system library. It's not part of the standard library, and I don't have NumPy anywhere here, do I? So I need to install the NumPy module. How do I do that? If my Python interpreter is set up correctly, right? So I have which Python here. You can see I'm using something called PyEnv. We're going to talk about that stuff in a moment. But basically, if I check the version of Python, I've got 3.7, and that means I have pip here. And what I can do is just pretty simply pip install NumPy. And what that does is it goes off to the internet and it tries to install NumPy. Now it's saying I've already got it installed here. Let me quickly, I think it's just uninstall. Yep, there we go. Yes, I want to uninstall it. Okay, it's gone now. Let me install it again. Goes off to the internet, downloads it, or it uses a cache if it's already downloaded the exact same version, and it installs that package in my local environment. And now I can import NumPy and I can use it, and I can run this program. Oh, if it's, did it freeze? What's going on here? Yeah, there we go. And basically, we're just demonstrating some basic use of NumPy where what we're doing is actually getting the number of dimensions of the array. So you can see in this first example, there's 0 dimensions because it's not even an array. In the second example, there's 1 dimension because it's basically 1 array. Then we have an array of 2 arrays. So that's 2, 3. So that's just something that we get with NumPy that we're showing you off that we're using it. And that's been installed through the pip package manager. Now, Justin asks a really great question. Hey, but it's not in the folder, aka NumPy has not been installed here. But remember I said earlier that there's 3 locations that Python looks for packages. So it looks for local packages, it looks for packages in the standard library. So standard library first, then local packages, and then what it looks for is any Python package on the path. So pip3 has installed, or pip has installed NumPy to one of those path locations. And again, I want to turn off that Git extension. This is a new window, so it's come back, unfortunately. Yeah, reload. Now, some questions about, we don't use NumPy in the project or anything. I'm just demonstrating a really popular package. So we don't actually use NumPy. However, it's an awesome library. You might use it in yourself in the future. So yes, Justin, NumPy is not installed to the local directory. It's not part of the system library. So it's installed to somewhere on that system.path. Can you also do pip I NumPy? I'm not sure. It might be. I know you can do that with JavaScript and stuff. What does line 1 mean again? Basically, we can import numpy, and then we can do numpy.array, numpy.blah, blah, blah. Or what as lets us do is just rename it. It's nothing crazy here. It's just renaming what that import is. So it's got less characters because programmers hate typing, and then we can just call it with less characters. That's all the as is doing. Why didn't I use pip3 install NumPy? I've got a different way of configuring my Python interpreter so that Python is 3.7 and pip, it follows a different sort of version level, but it is the pip for 3.7. You might have a different setup, and we'll talk about virtual environments. What I'm doing is using what's called a virtual environment, because I need multiple versions of Python installed on my system for different projects, so I can switch between them for each project. But we'll talk about that in a little bit in a moment. So Ricardo asks, what is the path? I assume you mean what is the path, or where is it installed to? And I actually think it's giving it right here. Is this in alphabetical order? Let's see here. Maybe not. But basically, if I go import sys and I print sys.path, brackets, excuse me. Oops. It is going to be installed in, let's see here, not there, not in the Python 3.7. It's going to be here, site packages, basically. Or one of these, dynamic load. It could be one of these two. But basically pip manages that for us, and it might even change between versions of pip and things like that. So we don't really have to worry about it, but it's basically one of these. It's not the Python path, it's one of the package paths. What's NDIM mean? I don't know. Oh, that's just the name of the number of dimensions. It's just the name of some NumPy thing that we're calling. We don't really want to worry about that. Why do we have a warning on the first line? I think it's just telling me that I'm not documenting my code properly. So it's telling me it wants it there to have doc strings. We don't have to worry about that. Okay. Let's see here. So that's importing install with pip. So we covered that. You just run pip install, and typically somewhere in your home directory. It depends on the system. It depends on the operating system, but somewhere on your computer, it's going to install that module. Now, what are some of the issues or problems that we can run into? How do I share the modules that I need for a particular project? And how do I ensure that my project doesn't end up accidentally using modules from other projects? Because if all the projects get imported to some shared library directory, then I could be accidentally importing them in my projects, and then when I want someone else to run my code, it won't actually compile. To solve this problem, we have what is called virtual environments. They're really cool. They can be a bit annoying sometimes to set up. But they're really helpful, and so let's talk about them a little bit here. So first of all, we have some links to some getting started tutorials. We're not going to go through those now, but if you're going through the lecture content yourself, you can feel free to jump in and have a look at some of the instructions there. Now, again, we have a note here. You may be asked questions about virtual environments on the exam for COMP1531, but you will not need to use them. But what we want you to think about is conceptually, why do we have them? How do they help us? Why are they important? And the reason why we're covering them, but we don't cover it in the project, is because they are used all throughout industry. So it is worth getting your head around them. And they're often used for CI, continuous integration or continuous development later. We'll talk about that another time. So let's actually, set up a virtual environment. Now, the most common virtual environment, well, I don't know if it's the most common, but one of the most widely used virtual environments is one called virtualenv. And you can see here that it's a package available in the pip package manager. So just like you install any package, we can install pip install virtualenv. Now I've already got virtualenv installed, so it's not really going to do anything for you. It will download it and install it. And again, just to clarify, whenever we do a pip3 install, some module, that module is installed globally on your system. It's not specific to the project. What we're doing in this virtual environment demonstration is showing you how we can have specific local package management. Okay, so we install this module called virtualenv. You do not have to do this yourself because you don't have to use the virtual environments. If you want to follow along, you can. You do not have to do this. You just need to sort of know about it and that they exist. Okay. Then what we do here is we are calling the virtualenv module and we're giving it a path. And in this case, that path is called venv. Now that path is a local directory, and you can see that directory is just here. And so it basically sets up a bunch of stuff in this local directory. It's got this bin, it's got this lib, it's got this git ignore, it's got some random stuff that we didn't create, that it created itself. Sorry, and just to clarify, on my system, pip3, whoops, go away. Pip3 and pip are exactly the same. They're both the exact same version of pip. It might be different for you. Yeah, again, it's because I'm using a virtual environment. So my Python package manager and my version of Python is always pointing to the correct version that I specified. So yeah, sorry about the confusion there, but it's the same for me. For you, it might be different if you've got Python 2 installed on your system and Python 3. But when you use virtualenv, you won't have to worry about that. Okay, so we set up this virtualenv directory that we just ran here, and then we can actually sort of activate that directory. So we source some thing called activate in venv bin activate here. So we source it, and something's actually changed here. I don't know if anyone's caught it, and actually my video here might have covered it. Maybe we can put this here. But if anyone with some keen eyesight noticed, this thing here popped up in my terminal. Now this is something that's specific to my terminal. If you don't see this, nothing's wrong with your system. But what it's trying to show me is that I'm in a virtual environment, and the virtual environment is actually called 2.4. Now why is it called 2.4? Well, pretty simply, I'm in a directory called 2.4. So it's named my virtual environment, the name of the directory that I'm CD'd into. But what does this mean? It means when I now check, hey, where is my Python interpreter now living? It's not living where it was before. It's living inside of this virtual environment. It's a different version of Python. It's a different copy of Python. It's a virtual environment. That's why it's called virtualenv. It's a copy of almost like a mini operating system with its own copy of Python and its own copy of packages. And so now, if I install, oops. And again, this happens to pip, right? Pip is install this virtualenv. So now if I install pip install numpy, it's installing it not to my computer, but to my local virtual environment. And again, you can see I already had it installed, sure, but it would install it there. So now there's actually 2 copies of NumPy on my system. There's one on the global system and there's one on the virtual environment. Already you can see how this might help us. If I have a separate project that also uses NumPy, but it needs to use a different version of NumPy, now I can have 2 virtual environments, 2 versions of NumPy, and all my systems work together, and I'm happy, right? There's something even cooler that we can do here. So we have this NumPy package installed in this virtual environment. I got my code working and it's running great, okay? I can prove that. I can run Python npy, that's the name of the file here. Again, this is running inside the virtual environment. And when this decides to eventually run, you can see that output. Awesome. Now, I want to send this project to my team member, and I want them to have the exact version of Python and NumPy that I know we need it for it to work. So we can actually freeze our installed modules at their installed version and pipe it out to a file called, we're just going to call it requirements.txt. This is the conventional file name for what we call, where we pipe out the output of a freeze. Now, if we look at that requirements.txt, you can see, hey, in this project, we have one module and it's called NumPy. What version of it? It's this specific version. Okay? And then we can install based on what's listed in this requirements file. So what I can actually do is I can come along and go pip uninstall NumPy. I've uninstalled NumPy, yeah, get rid of it from the virtual environment. I'm getting rid of it from the virtual environment, not my system. I clear that out. And now, hey, rather than installing NumPy, can you just install everything in requirements? And you can see that it's gone ahead and in my virtual environment, it's installing NumPy at that specific version. And that's requirements. When I want to leave my virtual environment, I just have to call this thing called deactivate. And now, again, those of you with keen eyes know that virtual environment is gone. If I check where my Python is now, it's a different Python on my system. Again, let's wrap up where a user-defined package can be found. So first of all, it could be the built-in system libraries. They're just by default available in Python. Okay. Then it could be installed on the system, basically in system.path in one of the directories in the global system path. So somewhere on your actual machine's directories somewhere. Then it could just be installed somewhere in your home directory because the home directory is also on the system path. So these two are very similar. And you can see here the difference is that if you sudo pip install, it's going to go onto the system path. Otherwise, it's going to go just for the user in the home. And then finally, we have something like virtual env where it's just in the project directory. But if we have a virtual environment, we no longer need to look in 3 because we're running Python in a virtual environment. There is no system environment. So we only have to look in the virtual environment. Okay, I think that's it for this content. Let's have a look at some of the questions. I should also send... So the QR codes for this feedback aren't the right ones. Oh, I've got it here. Some lecture feedback so far. I know we sort of flew through some of this stuff, but when you rewatch it, it's going to make a lot of sense, and we've got links for you to go off and do some of these things yourself to play around. So, some questions. Kanye is live. Don't know how that pertains to us. I'm much more important. It's like cubes. I don't know what that is. Something about projectors. What is the main purpose of a virtual environment in Python? The main purpose of the virtual environment is to stop the situation occurring where we have you on your system, on your computer, you have multiple Python projects. So you might have the COMP1531 project, and you might be working at an internship and you've got a Python project for that. Now, project A needs NumPy version 2, project B needs NumPy version 1. You can't install 2 versions of the one module in your system because it's just going to install NumPy and override it, and then you can only have one. What virtual environments lets you do is have localized virtual Python execution environments that have their own set of modules that you can install and uninstall and do whatever you want with that are isolated from other modules. What does -m mean? It means invoke the default behavior of a module. So you're saying, hey Python, I want you to run PyTest. PyTest isn't a file, it's a module. It's telling you that it's a module. Awesome, Joshua, awesome. And then it also has added benefits of generating these requirements files that specify exactly a frozen version of what version of NumPy is. And now the last thing I'll end this lecture with is that anyone can publish Python modules. They go to what's called I don't know what it's going on with it, whatever. But this is the official Python package manager or package index, there you go, Python package index website. When you install pip install something, it's coming from here. And anyone can make their own projects that they publish as Python projects. In fact, here's one that I wrote myself in 2020 and published, and it was a tool to import students into Microsoft Teams. And this was because the pandemic was hitting and we really had to get all the students into Teams, and Teams didn't have a way to bulk import students. So we had a few different teams around the university. This is a different university that we're trying to get everyone into Teams. So everyone's trying to like run this script. So I thought, okay, let me write a little Python project here. Yep, it works. I'm going to publish it as a Python package, and then people at the university could just run, hey, pip install Teams import. They could call Teams import, and it could do the functionality that we needed them to do. So anyone can create Python packages, and you can even see some statistics here on like what the most popular package is, or whatever. Did it work? Of course it worked. We got all the students in overnight. In the entire faculty. It was pretty cool. And you can even go into it and see, I don't know if you can see the actual source code. We can download the files and you can see the source code there, but it's all there. Yeah, -m runs a module, not a Python file. Exactly. Okay, any other questions on this stuff? Flex, yeah, exactly. Another last thing you'll say is there are different approaches to virtual Pythons and Python management. VirtualEnv is a little different to something like PyEnv. PyEnv is what I use to pretty simply allow me to have multiple versions of Python installed on my system, and I can switch between them if I need to. So this is just what I use personally and something I recommend. Yeah. Okay. Again, that's the wrong link. Don't scan it. I sent the link for the feedback in the chat. I'll send it again. All right. Let's have a 10-minute, no, not 10 minute, maybe 7-minute, sorry, 7-minute, did that work? Yeah. Do you want to have a 7-minute break, get some water, make a coffee, go to the bathroom, do whatever you need to do, and we'll come back and continue on. Can we have multiple virtual environments in one system? Absolutely. That's the whole point. I could have 100 virtual environments for all my different projects with all my different versions of Python and all my different packages. Absolutely. Cool. All right, guys, go have a break. Let's get the tunes back. I'm going to refill my water bottle. Okay. You guys coming back? Let's see, how many people are here actually? 110. Not that many. Sad. But for those of you who are here, much appreciated. Now, I know some people can't make it, it clashes with other things, etc. Alrighty, we'll give it 1 more minute. The rain has stopped. Things are looking up. Make sure you download the PDF notes if you want to follow along. Yeah, it's my fancy. I like it because you can like just hold on to it like with a laptop. Just like it goes into a bag very nicely. It's good. Link in bio. I'm not answering that, RN. You can guess, but not publicly. All right. Yeah, sponsored ad. That'd be cool. Start making some cash on the side. Okay, 10 past. Let's get into it. Yeah, too much coffee. Exactly. Yeah, we'll give people a couple minutes. So we've got 2 more lecture content topics today. Exceptions, which are really cool and important, especially for the project. You can't, I'm 20, what am I? I'm 27, there you go. Hopefully you thought I was older than that. I'll be sad if you thought I was younger. Alrighty. Yeah, give up. It's all over. Alrighty. Let's get into it. Python 1531, sorry, COMP1531, lecture 2.5, exceptions. So all programs that we write, programs that you wrote in C, programs that you write in other languages, will sometimes come across states or situations in which the chat's making me laugh, in which the program encounters unexpected values or variables or state, and it's not able to continue doing what it was trying to do, and it crashes. What a crash is most of the time within a program is it's a thrown exception that tells the operating system, hey Windows or hey Mac OS, I can no longer keep running this program. I've got to give up. I don't know how to handle this, and it's game over, right? That's throwing an exception. So it's an action that disrupts the normal flow of a program, and it's often representative of an error being thrown. And exceptions are ways that we can elegantly recover from errors. Sounds good. A program that never crashes. Okay. So in this lecture, we're going to look at a few different ways in which we can respond to erroneous states. You can't see the slides. Of course you can't. How embarrassing. You didn't miss much. So exceptions is an action that disrupts the normal flow of a program. It's often represented as an error being thrown. Okay. So we're going to go through basically a sequence of examples with an erroneous program that's going to crash, and we can show how we can use the built-in Python tools to recover and handle those situations. Okay, so the first example, let's get 2.5 up, resize my window. I should have done this on the break, I apologize. Let me quickly uninstall that Git thing. Alrighty. Exception 1, here we go. So here we have a really simple program with a method called square root that takes in a number and does the square root of it. Now you can't take the square root of a negative number. So basically what we're saying is if the number that was passed in is negative, basically exit with an error. This is equivalent to there being just an error that gets thrown in the project. Okay, and we write out to the standard error console, hey, there was an error. So let's run this program. Let me know if you can see the code okay here. Okay, so Python, exception 1 is the name of this file, and we need a, let me just go one more out. We need a parameter, I believe. No, we don't. It just reads it in from readline. So please enter a number. So what number are we going to take the square root of? Let's just get the number 5 or whatever. Okay, we calculate some number. That's fine. Well, what if the user enters in a number that can't be handled, like -5? Well, we throw an error. Okay, there was an error. The input was less than 0. We can't handle it. And what's happened? The program stops running. Yeah, I don't know why we're using readline here and not just read, but whatever. Just showing you different ways that we can do things, hey? So standard input read line is the same as just doing, read, please enter a number, whatever. So what's important to note here is that when we came across this error, the program threw the error and kicked the bucket and stopped running. Okay, the program is not running anymore. All right, so we just didn't handle this error. There's many ways or in types of sort of situations where something like this will happen. You will come across it many, many times. You will write many programs that crash. You will write more programs that crash than programs that don't, right? Crashes happen all the time. What we're talking about today is how we can handle those crashes and recover more gracefully. So in this example, what we're going to do, rather than just crash to the terminal, we're going to raise an exception and give a little bit more information about what's going on. So in this example, you can see it's quite similar, but rather than just crashing and exiting, we're going to raise an exception, and when we raise an exception, we can give it some information. Basically, we're calling a method, right? And we're passing in a string. This is an F string that passes in the value X, so we can look at the value when we realize something goes wrong. So now when I run the second version of this, Python 2, please enter a number. Let's put in -5 again. Okay, we still crashed, but an exception was thrown. And the exception is telling us, hey, there was an error. The square root of input -5 is less than 0, and I can't handle it. So what's happened here? We've crashed all the same, we've thrown an exception, but we're able to provide some logic that's happened before the crash sort of completed the execution of our program. And in this exception, we were able to raise what the actual value of X is. And so you can imagine just how useful and important it is to understand why the program crashed. Well, here's the actual value of X. Maybe that can help you narrow down what went wrong. But in this example, still, we're raising an exception. Sure, we get a little bit more information, but we're not recovering from it and we're not dealing with it. And so here we have the third example. We can catch raised exceptions. So what's going on here? Whoops. Let me clear the console. Move this down a bit. All right. The square root method here, or the function, is exactly the same as the version before. We're throwing an exception, no differences there. What's changing is down here when we're calling that method. So again, this is all exactly the same. Please enter a number, we read a number in, and we call square root on the number. But what's changed here? What's going on? This is all it was before, but now it's in this funky thing called a try statement. Now, this is not a Python-specific language feature. This exists, like Steve has mentioned, in C#, in Java, in a lot of OOP languages and other languages like that. So what's going on here? We have this, what's called a try except block, or a try catch block. What we're saying is that, hey, Python, I know I'm about to call some code that's a bit iffy, right? Square roots, I don't know what my user's going to input. I know that the square root function can raise an exception. So therefore, I don't want you to have a meltdown when there is an exception. I just want you to try it. Try doing it. And you can see these 3 lines here are exactly the same as these 3 lines. So it's like, try doing these 3 lines. In the case that there's an exception, don't freak out. I'll tell you what to do. And that's what these 3 lines are here. And what are we telling it to do? Look at that. We're just doing it again. We're printing out the error. We're printing out the exact exception that was thrown so that the user knows why it didn't work, because it was less than 0. And then we're just saying, hey, dude, do it again. Let's run this. All right, here's the first time I run this. Please enter a number. Whoops. I don't know what I'm doing, and I enter in -5. I hit enter. Okay, let's see what happens. We raise the exception, but it gets caught, and this block executes, and it prints. Hey, there was an error when inputting, right? Then we printed the exception. What was the exception? The exception was this string. The details of what went wrong. There was a square root of -5, that's less than 0. Please try it again. And then I'm just saying, try it again. If I put -5 in again, what's going to happen? It's not going to work in this time because this was not tried itself. Right? So this time when the exception was thrown, the whole program falls apart. But let's do it one more time. I put in -5. Let's try again. I put in 5, and now I get my square root, and it works. Whoa. Something just went wrong. I got to stop slamming my desk. I'm pulling a cable out, I think. We're a bit better, a bit closer. We're handling the exception, but it's not perfect, because as you saw, if I get it wrong on the second time, I'm still throwing an exception, and I don't want to really put all of this in another try, with another except. You can imagine it's just getting nuts, right? So we don't. Whoops! I'm just going to undo that. We don't want to do that. Okay. Now there's a question as to why we're using standard in read line. We probably shouldn't have. To be honest, we just should have done read. Is it read line or is it just read? Yeah, it's just read. It's equivalent. Read is just calling. Whoops, my monitor is going nuts. Standard input read line. It's exactly the same. This is a different way of doing it. Input, yeah, of course, input, not read. Okay. Now, someone also asked, what is this E? When I catch an exception, I name the exception a variable. So this E is just something that I've named. So this could be like, my exception. Oh, I shouldn't do that. And that's going to work just the same. But it's typical to call a thrown exception E. That's typical. Alrighty. Yeah, it's input, not read, sorry. So that should be, input, input, none, like that. Same thing. You don't have to worry too much about that. Okay. Any other questions here that I've missed? Maybe, maybe not. That looks okay. Alrighty. So again, are we all understanding why this is good but not great? Because I need to keep trying and catching, trying and catching. How can I solve that problem? We can use a loop, right? We're programmers. We don't rewrite code. We're not animals. We repeat our code when we want it to repeat. So if we look here, again, we have the exact same square root function. And here, what have we got going on? Please enter a name, and I'm just, yep, because I know you guys are all... please enter a number. Then we have a loop, right? Now, remember from your C days, what happens if you have while true? Come on, I'm asking the chat. Yeah, infinite loop, goes forever, just keeps looping. That's right. So we're in a loop here that's just going to keep running to infinity and beyond. Yeah. But in that loop, we run this block of code, and we have the try block. So we call the square root function in the try, we print it out if it works, and then we break. And this break, exits our infinite loop. We are done. We successfully got the square root, right? But if it threw an exception, we just say, hey, there was the error, please try again, and we don't break. So what happens? We come back to the start of the loop and we try again. So let's run this. Oh my God, something is really going wrong with my monitor. Give me a second. I think I've pulled out a cable. Jesus. Hold on, guys. I gotta just unplug and replug something. Okay, we're back. Is everything working? I think it's all okay. Oh, my monitor's gone again. Okay, we're back. Is everything okay? Hopefully. Come on, chat. Pull through. Where's my YouTube slides? Yeah, 106. Okay, that was still live. That's good. Okay. So we loop, basically. Okay, so what was it about? Sorry about that, guys. Okay. Hopefully this is actually okay. We back. All right. Okay, I was demonstrating it. Let's just do that again. So I cancel that, clear that, run that. All right, please enter a number. So let's say I get it wrong and I do -5. We come through here, we have our loop, we check the input, we try and square root it, it throws an exception, we catch the exception, we print out the error, and then we run back to the start of the loop and try again. So when I do -5 this time, we're in a loop, whatever, forever until I put a number in that it can find the square root of. The loop then breaks and we're happy. And this is a really common way of reading in user input to a program where we need to sanitize the user input because it could throw an exception. So basically we get the input from the user, we try to do something with it. If it doesn't work, we catch the exception, we tell the computer, hey, don't stress, we try it again. Okay, so that's with our loop there. Now, so here's a problem that I'm going to propose to everyone. This program crashed at this point, or we're through an exception at this point, because x was negative, right? We all agree? That's the reason we threw an exception. But what if this function could fail for multiple reasons? And Justin, with some sort of clairvoyant question there, has intuited what I'm going to talk about next. What if there are more specific errors that we need to catch and detect? This is just the generic exception, but there could be multiple things that go wrong, and then I'm catching every potential exception, assuming that I know how to fix it, but I might not. I might think the value is negative, but that might not be why the program crashed. So because exceptions carry data, we can put data in the exception that gets raised so that we can understand if we should actually be handling it in the correct way. So here's another, let's see here. Throw catch, here we go. Here's another example here, where basically, so I think this is exactly the same, but we are now, let's see here, bringing in the values from argv. So let's see here, if I go Python, whoops, yep, Python, clear that up. It's called throw catch. And it wants the number that's going to be converted into square root, so let's put -5, for example. We get that same exception here. -5 is less than 0. We can't square root a number that's less than 0. Okay. But what if the reason for the error is that I don't give... well, in this case, we're sort of handling it in a different way. We're just saying that the length of the arguments is equal to 2, so only do it if we try. But what we can do here is that we can change the type of exception that gets raised. So another common one is that the issue with this particular function is that x is the wrong value, right? So we can raise a value error. Now, I believe if I run this, this all works just the same. We raise a value error, but I'm still capturing the exception and printing got an error. Okay, why is that working? Well, a value error is a more specific type of exception. So if I catch the exception type, I'm capturing all exceptions, including value errors. Okay, but let's swap this. So let's raise an exception, but I only want to catch a value error. What's going to happen here when I run, whoops, save that. When I run this, again, those of you who have keen eyes, you can see that it did not actually catch and run this exception. How do I know that? Because this, when it's caught here, we are meant to print got an error, but it did not print got an error. It just printed this exception, and then the program crashed. So what we're trying to demonstrate here is that if I'm throwing a value error, I need to catch the value error, or I can have like a default. What's common is you have a default exception case here as default exception, let's call it, and print. Okay, now I really don't know what to do. Just log this and quit. Is it lowercase a? Or is it's sys dot exit, I think. And I can't spell. So now you can imagine that, like, okay, got a value error, I know what to do. So, now what's wrong with, is it not sys.exit? Oh, it's just lowercase x. Sorry about that. So now, we can see that, okay, if square root throws a value error, I haven't done anything really here, I'm just printing, but like, don't worry, I just need to get a new, get more input from the user. But if it's something else, oops, I don't know now. But you might still have something you want to do, like log it to some global logging system. And when I run this, what have I done there? Go away. Throw catch with -5. You can see because I raised an exception, we get that I really don't know what to do. So it only jumped to this exception catch. But if I made this a value error, we get the value error branch that ran. So we can handle the different types of errors that run. And we're not going to do this in this lecture, but we can actually define our own exception types. So you can have custom exception types that occur, that you can raise whenever you want to raise. So Zach's got a question. Wait, so value error is triggered as an error whenever what happens? Value error triggers whenever a value error is raised. He's Googled it. Okay, that's fine. So when a value error is raised, we can catch that exception. If a value error is not raised and some other error type is raised and there's some other built-in ones, exception will catch it instead. And it's the first one that catches it. So it doesn't, so even though a value error is an exception doesn't catch it because value error already caught it before. Does that make sense? All right, we have one more important thing to talk about here with exceptions and PyTest. This is really important for the project. So pay attention here. Again, we've got this example here. Square root throws an exception, blah, 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 blah. Now, square root, if it's working correctly, should throw an exception if the value is negative. Agreed? So if it should throw an exception, we need a way with PyTest to check that it threw an exception correctly. The test should pass if the exception was thrown. Now I know that might seem a little bit backwards, but it makes sense. If PyTest works correctly, it should throw an exception when the value is negative. And so we can write a test to check that the test suite that runs actually raises an exception. So let's test this. So I run PyTest this time, right? Not Python. I'm running PyTest. I want to run it on this PyTest 1 example. And you can see all my tests pass. Now, what's happening here? I've got 2 test methods. That's why it collected 2 items. In the first test method, I just have 4 assertions, and they assert that the square root of a number is the correct number, right? The square root of 4 should be 2, 9 should be 3, 16 should be 4, etc., etc., etc. That makes a lot of sense. But here, we have syntax that says, hey, run square root with a negative number. And I don't want to assert anything. What I want is for there to be an exception raised. Now, something to keep in mind is that only one of the lines within the block needs to throw an exception, not all of them. So for example, this is not going to throw an exception, this isn't going to throw an exception, but -3 will. If I test that, it's still going to pass all my tests because in this block, an exception was thrown. However, if I get the square root of 9, now, are any of these lines going to throw an exception? I'm waiting for you, chat. No. Nay. Very tricky. None of these lines are going to throw an exception. So I want my test suite to pass because that must mean that my function isn't doing what it's meant to do. So the thing with exceptions is that it's not like you never want to write exceptions because if you write an exception case, you're a bad programmer that's writing erroneous code. It's that sometimes we know things that we want to do in programming, in our programs, aren't actually possible. It's not possible to take a square root of a negative number. So what should the program naturally do? It should raise an exception, and you need to build that functionality in. You will need to build that functionality into your project, and you will need to test that exception functionality in your PyTests. And this is the syntax to do that. So you're not testing your tests, you're just testing that your code raises exceptions when it should. Keenan asks a good question with the previous stuff. If you raise a value error and only have an exception, will the value error be raised? Absolutely. In this example, if we didn't have this, default exception would be of a type value error. So hopefully that answers your question. So again, nothing really new happening here. PyTest just has some syntax that allows us to test that a set of tests at some point should throw an exception. How are we all feeling with that? How has this lecture sat with us? Good, bad? Let's take a moment to reflect, to think if we have any questions for Jake. I'll give you guys another example from the project. If the user wants to sign up to an app and they don't put in a valid email, I can't sign the user up. I need to handle it somehow. Maybe I throw an exception. That's an example. Okay. These two slides are exactly the same. We don't have to worry about those. Yeah, that's everything on PyTest. All we're talking about today with PyTest is that you can test that exceptions are raised. And you can test that the specific exception was raised. So this test should also fail because exception is not a value error, which is a different type of exception. And the test will fail because a value error exception was not thrown. So someone's asked, magic, write that down. Yeah, that's all the section. Can you re-explain value error? There's nothing sort of crazy to it. Let me just... what's going on? Go here, sign in. So basically, you've got, yep, can you all see that? Yep. You've got the exception class. I can throw and raise these exceptions, but they're very generic. It's like I don't have any details about the exception. But I can have a subtype of exception. One is called the value error. So value error is a type of exception, but it's got a bit more context. It's like something was wrong with a value. Now, value error could have a subtype of exception, or exception has other types of exceptions. And we can look at the built-in exceptions. And let's see here, blah, blah, blah. Let's look at them all. A floating point error, an assertion error, a key error, like the key, you can see there's a lot of specific ones. An index error. I looked at an element in a list at the wrong index. And one of these is the value error, raised when an operation or a function receives an argument that has the right type, but the inappropriate value. So why did I use value error for that? Because that's what was happening. I received an integer, yeah, I'm happy, but it was negative. So it's the right type but the inappropriate value, and it's not described by anything more precise. So it's, for example, if I was using that value to look up an index in an array, I could throw an index error, but that's not what I was doing in this case, so I threw a value error. And you can write your own exceptions that are even more specific. So Ella asks a good question. How do we verify the function not only raises an exception, but also the correct value of the type? So the specific content of the error string. Ooh. Great question. So I guess what Ella is saying is, let's say this raises a value error. And it's raising this string. How do I test that? I actually don't know the syntax for that. PyTest. Well, if we had the normal code, it must be possible. We can do as E, and then we can do like assert E is equal to whatever my string is. So let's see here. PyTest exception get the message. How do I probably assert the exception that gets raised in PyTest? Let's have a look here. PyTest.raises exception. Oh, there we go. There's the syntax. Ella, great question. We can use this as e-info, really similar to the as syntax here. It's the exact same syntax. And this creates us that e-info thing. And then we can actually also assert that e-info is that the syntax? Yes, is equal to, and now let's look here. We want to assert that the square, no, that won't work. Unless it's actually changing. Let's see here. Let's print e-info. And then, yep, let's just do that. That should, I don't know if that will print it, but let's have a look. It might not print it because it passed. Already at that point. What if we do that? No. PyTest print to the output. How do I say normal print creating through a PyTest? Running a bit of time here. The -s switch. What? That didn't seem to work. Now this is saying, no, how do I just view print? Again, sorry, whenever we have the as keyword in Python, I'm picking my own name. I'm just choosing the name of it myself. This is going to be a little bit hard to set up, I think. Use PyTest-s, isn't that what I just did? Maybe it needs to be back here. Nope. Oh, S, not D. I'm not getting it. Oh, is that it there? Exception info. Raises for context. Okay, we're wasting a bit too much time here. It's a great question, actually. If someone can figure it out, that would be good. What I'm not sure about is because if I make, this is the reason I was unsure, if I make 3 calls here that have negative values, I should get 3 exception information values back. So what I wasn't sure about is if PyTest reassigns info basically each time. You know what I mean? But I can't figure out how to print it out at this point, and we're not going to spend too much time on it. But a really good question, Ella. If you go off and look at how to do it, let me know and I'll talk about it. Okay. Stephen asks another really good question. Is there a way for Python to let us know what type of error it caught instead for us to specify what error we are expecting? If I understand your question, absolutely. So if Python throws an error built into the language, it's going to pick the appropriate error to throw. And if we're catching all errors as an exception, we can see usually there's something on the exception object itself that tells us sort of exactly what type of exception it was. So for example, it might be the class here that is, let's have a look. If I throw a value error here, and we're getting sort of out of scope here, but it's interesting stuff. Looks like it's saying it's an assertion error. I was hoping to get this. Oh, I didn't print it. Let's get rid of that. There we go. You can see that even though I caught an exception, I can check what type of exception was thrown, and it was a value error thrown. So hopefully that answers your question, Stephen. And depending on it, we can do something else. But what we generally do is we just catch the value error specifically. All right. Lecture 2.6. No more code here, no more Python stuff. We're talking about something that you'll be doing in the project, something that has been near and dear to my life in good ways and in bad ways for many years. And that's basically modern Agile practices in software engineering. Agile has to be one of the most thrown around tools in modern software development ever. It's up there with machine learning and AI. Everything's Agile. What does it mean? What does it actually mean? And when we ask you to work in an Agile manner, what are we actually asking? Now, I've mentioned before about my time in industry. We were an Agile development institute or development lab. So we worked in an Agile methodology day in and day out for the time that I was at that place. So I have my own experiences with Agile. Other people have their own experiences with Agile. It's a very loose term. It's sometimes problematic. It's sometimes done well. It's sometimes not done well. But we're going to talk about some basic practices that are really common and core to any implementation so that when you go out into the industry and you get told, we're Agile, you know a little bit about what that means. So what is Agile? It's about working dynamically with agility to solve specific problems with a dynamic scope in a specified time period. It's about responding to change quickly. It's about responding to what your customer or what your client or what your users want and need quickly. It's about dynamically adjusting what's important and what's the top priority in your project quickly with agility. But that's all a bit of philosophy. How do you actually do it? And the answer is there's no agreed definition of what Agile is. You know, there are huge firms that charge lots of money to go to companies and consult, and then they help them teach what Agile is. But if we take a step back and we talk about what happened before Agile, typically software development projects utilized what's called the waterfall software development lifecycle. And in the waterfall method, you start with requirements gathering, you design your solution, you implement your solution, you test it, and then you evaluate or you deploy and do some maintenance. But typically, actually, the last step in the waterfall method was evaluation. So did what I did work. But this waterfall cycle could take 6 weeks, 8 weeks, 6 months for a particular feature. And that's just too slow for modern software. There's some more information on how, this is the thing about Agile, right? Where we're taught and that these consulting firms come along and they say, look, Agile solves all the problems that came from Waterfall. But I mean, Waterfall was used to create successful software for decades. NASA put astronauts on the moon with waterfall life cycles. They weren't doing Agile consulting and all that stuff. So don't buy into the hype of Agile too much, but there are some things that are defining about Agile software development and that actually do help and are generally agreed to be sort of useful. So iterative and incremental work. We don't release huge project changes at once. We release small, iterative, incremental changes. We have quick turnover. So if there's a demand or a requirement, we quickly develop a minimal viable product and we push it out. And we're light on documentation because what we're focused on is getting it out quickly. We can document it later. These aren't necessarily bad or good things, but they are just properties of Agile development. Really, documentation is something that we really don't pay enough attention to as an industry as a whole. So what's Agile good for? Your resume. You want to be updating it all the time, little changes. You don't want to wait until you're applying for a job, you're exhausted, it's 2 a.m., you finish your other job, and now you've got to put 5 years of changes in your resume. No, work on it with some Agile practices over time, and you'll be really happy when it's 2 a.m. and you can just submit it. Changing requirements. And the project that you'll be using in 1531, you'll be working on it in an Agile methodology. So one core tenet of the Agile methodology is the stand-ups. The dreaded stand-ups. Every single day, I was in industry, every single morning at 9:05 a.m., we had a stand-up within our teams. So I was on a team with about 3 to 5 people. When we were in office, we would literally physically meet. You would physically stand up. The idea of a stand-up is that you don't sit and spend too long in a meeting. Stand-ups are meant to be really, really short. So 5 minutes snap meetings. So that's why they're called stand-ups. You don't want to sit down and slouch and take too long. Traditionally, everyone stands up, sure. And you answer 3 questions. What did I do? So typically you'd say, what did I do yesterday? Because you're having these every day. What problems did I face? So am I blocked on anything? Did anything stop me finishing what I wanted to complete yesterday? Excuse me. And what am I going to do today? And you just repeat that every single day. Now, because of COVID, you can't stand up physically in the same space. So we have these asynchronous stand-ups. And basically, so when I worked, so at my lab, when we started having asynchronous stand-ups, and actually some projects even before COVID had asynchronous stand-ups, what we actually had was a Slack bot in a channel on Slack, and every morning at 9 a.m., it would ping everyone in the team and be like, please type your stand-up, please type what you did yesterday, what you're doing today, what you were blocked on, blah, 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 blah. So you don't have to find, and you can do that, not everyone has to respond exactly at 9 a.m., so that by the time it's 11 a.m., you can read and see what everyone else is doing. However, it's not as good as an in-person synchronous stand-up because you can't say to your team member like, Annalise, for example, oh, you're blocked on that. I can help you with that. I've already solved that problem. So you can't do that with the asynchronous. Or you can, but it takes a bit longer and it's less personal. We also have the task board. These are what we use to track what activities everyone's working on every single day. Because Agile, people work on more things for a smaller duration, we need a way to track that. Now, part of the project, you have to actually track using a board your particular project. So if you go to a group, and you go to the project repo, you can actually see under, where is it? Under blah, blah, blah. Here we go. Under boards, under issues, you get a project management Kanban board for you for free. And you actually need to track, what everyone, I am working on auth. I'm not going to do it. This is a real project. And you can assign that card to specific team members, and then you can drag it around. And what you should do in the stand-up, so typically the project manager or the scrum master would stand up at the board and move the tags around to show the correct state of what everyone's working on. And you need to do this in your project. In fact, your tutor will actually look at your board and mark you based on how appropriately you've used it. So typically the boards used to be like in-person physical. I've done stand-ups with physical sticky notes, and now typically they're just online systems. So you have it available in your GitLab. You use it to track and store your progress on who's done what. You don't need that many columns. Typically you have your backlog. So that backlog is the things that you still need to do. To do is the things that, so backlog is all the things that you have that need to be done. To do is like what you're going to be doing in the immediate future. So they're your high priority items. Doing the things that you're doing. That's pretty straightforward. You might have a testing column if you want to have an intermediate step, and then you've got done. So what our sprints are, that you usually maybe once a week or once a fortnight, you're planning out, if we go back, that to-do board. What are we going to do in the next sprint cycle, which could be 2 weeks? So you align what your customers need, what your managers want you to deliver, what you think you can deliver in the 2 weeks. You put them on the board, you put them in the to-do, you triage, and then you start assigning them to people. We have some information there about, the sprints. So the time is fixed. So for example, if you're in a 2-week sprint, at the end of the 2 weeks, you always finish the sprint. If you did not finish the task, it carries over to the next sprint. Oh yeah, one more thing worth mentioning, specifically with software engineering projects, is that typically, not always, I never did this actually with my type of projects, but at the end of each sprint, at the end of 2 weeks, for example, if this was Spotify, we work on this, okay, we got this thing working, we release the new update to Spotify. And then you go on to your next sprint. Finally, meeting minutes. Every time you have a meeting, not a stand-up, you don't want to do this for every stand-up. Stand-ups happen to be really quick. Every time you have a meeting, a longer, more formal meeting, maybe once a week or once a fortnight, someone should be keeping notes. And here we have an awesome example of some minutes from a meeting that Hayden had in his industry. And this is a real example of a real industry sort of minutes format. You can see we have the date, who was present in the meeting, that's really important. What were we meant to talk about, and what did we actually talk about? Someone is usually designated to be the person that should be taking those meeting minutes, so make sure that you rotate that too. And you want to document the things I just spoke about. Who's there? When was it? What did you talk about? What were you meant to talk about? Finally, the last thing we're going to talk about in this session is the concept of pair programming. You've probably heard of it before, and it's not a complicated concept. It's when you are basically getting help from someone else on your team or someone who knows a bit more about something than you do, and you work at the one computer, the one keyboard, talking through a problem, and one of you is driving and writing the code and solving the problem. You can take turns in writing code, you can have the one person writing code, you can discuss it as you go, but you should be talking out loud about, if you know something more than the other person, what it is you know, so that you can impart that knowledge. And it's good for helping less experienced programming learn sort of small concepts or techniques from a more experienced programmer. In Visual Studio Code, this is where I'll leave you today. There is a really awesome extension in Visual Studio Code called Live Share, made by Microsoft, and it allows you to do virtual pair programming. So I've mentioned before, I maintain a software system with another person in another state. Both of us work on the system at the same time. We use this all the time. So when I get stuck on something and it might be in an area of the code base that I didn't write and the other person wrote. If we're both online, I'll send a message and I'll be like, hey, do you want to jump on a live share? What it does, it's actually quite cool, but it's authenticated and then it shares in live real time what the code that you're looking at is and even what the terminal is. So that if I'm helping one of you out on live share, which I'm not going to do, don't ask for that, I can see your terminal and run commands in your terminal remotely so I can debug the issue and help you solve what it is. So live share, really useful tool for virtual pair programming. Whew. We got through it, guys. There was a lot of content today. I am parched. As always, here is the URL in the chat for the feedback for the lectures. And this time we had the PDF slides available to you all. So I'm trying to show you that I'm responding to the feedback that you are providing. That was something that a lot of you were asking for. And what was I going to say? I'm parched now. 2 hours is a long lecture. But what was I going to say? Anyway, please give us your feedback there. By now you should really be getting into the project. Start talking to your team members about getting started, about understanding it. If there's things you don't understand, post to the forum and ask the questions at the forum. Oh my God, there was something I was going to say and it's right at the tip of my brain. There's something about the feedback. Anyway. Oh, okay. That's what it was. And I will, if one of you, once the video is listed publicly on YouTube, wants to go through and put the timestamps in, that would be really, really, I think because you just do it as a comment, right? Or something like that. If you do it as a comment, I can paste it into the description and I'll sort it out. But if one of you could go through and find the timestamps, that would be absolutely awesome because I think in this lecture we had 5 different topics or whatever it was. So it's helpful that they get broken down a bit. That's what I wanted to say. Okay, otherwise, thank you all so much for listening for the last 2 hours. I hope you learnt a lot. I know we covered a lot at pace, so you can go through and watch the videos later and understand what it is that I was saying and build your own mental understanding and mental models about what we're talking about. And like everything, get started with this. Start doing this stuff. If you do this stuff, it will make sense, I promise. And you will have a great time in the project. You will learn so much. And I know we push you guys in this course, but you know, I hope you can get from what I'm talking about. These are things I did every single day, earning big money in industry. Not really. I didn't earn that much money. Okay. Thank you all. Have a lovely day. Stay dry. And I'll see you next Tuesday.